All right, good morning, guys. We're going to have day 2 of solving right triangles, and as soon as we can get this going here. So we're going to take a look at you being able to make sure that you can label the sides of a right triangle, that you can set up the trig ratios, and that you can use the trig ratios to solve for both missing side lengths and angle measures. So first thing, you've got to have a right triangle. And remember, you're going to have to decide which method to use. So notice here you've got two side lengths of a right triangle, and you're going to be asked to calculate the length of the missing side of side HT. So label your sides. There's your hypotenuse and your leg and your leg. Remember that Pythagorean theorem, you only need to label it as legs. So we're looking for that length HT. You've got two sides of a right triangle, so you're going to use Pythagorean theorem. So now set up leg squared plus leg squared equals hypotenuse squared. So the leg is your unknown, so it goes on the left-hand side. Square the 9, square the 15. Solve your algebra equation. Subtract 81, and you're going to have the square root of 144. When you solve for that is 12. So the length of that side is going to be 12 units long, whatever that may be. We're going to use that same triangle now to set up the trig ratios, just as a quick reminder from yesterday. So now if you're going to set up trig ratios, we're going to start with angle H. Notice I've marked it with an arc that's orange over there. And labeled the hypotenuse, it's always going to be the same. Opposite leg, opposite from angle H, is 9, and the adjacent leg is the one next to H, and you just solve for that, and it is 12. So setting up the trig ratios, setting up for H. The sine of H is going to be opposite over hypotenuse, and cosine is going to be adjacent over hypotenuse, and tangent is going to be opposite over adjacent. So you need to make sure you have those written in your notes. All of these examples should be written into your notes as well, guys. So you're going to have 3 over 5, 4 over 5, and 3 over 4. Now, setting up for the angle A, notice I've changed the arc down to angle where angle A is, and we're going to replace or switch the opposite leg and the adjacent leg. So opposite leg is marked wrong. The opposite leg should be across. I thought that I had switched those, so just switch them in your notes here, guys. Make sure that this is adjacent leg here, and this is the opposite leg. And next is the tangent of A. So when you take a look at your trig functions, notice that they are switched. So let's take a look at this one. Let's see if this one's labeled better. So now you've got to calculate the length of HS. This triangle is different. It's a right triangle, but it's different in the respect that both of your angles, or both of your sides rather, are labeled the same length. You've got the marks there that tell you that each of those sides is going to be 3 radical 2. So we've got that, and we're going to use that now to use the Pythagorean theorem to find the length of HS, which happens to be the length of the hypotenuse. And setting that up, we're going to have 3 radical 2 quantity squared plus 3 radical 2 quantity squared, because those are the two legs, and that's going to be equal to x squared. And your x is equal to 6, although it was already revealed. We revealed it one more time. So your trig ratios for that very same triangle, we're going to start with angle S. You got your adjacent leg and your opposite leg. So sine of S is going to be 3 radical 2 over 6, opposite leg over hypotenuse. Reduces to be radical 2 over 2, and we're going to do cosine of S the same way, and then the tangent of S is going to be opposite leg over the adjacent leg, and so you're going to have, you're going to simplify that or reduce that to equal 1. Now, when we are going to change this now to angle H, so we're going to find the trig ratios for using the opposite leg and the adjacent leg this time, although they're marked correctly, which is good. And notice that this is one of those special cases because it's an isosceles right triangle. You're going to use your sine and your cosine of h, and sine and cosine of s are going to be the same as is your tangent of h. So we're going to move on to questions that say, if you're told that the sine of h is 6 over 8, how are you going to use that to find the cosine of a? Well, you're going to take and first draw a triangle and label it. So here's your triangle. I've labeled the angle A. Don't need to worry about anything else. Hypotenuse, opposite leg, adjacent leg, and opposite leg is going to be 6, and the hypotenuse is 8, because remember the sine is opposite leg over the hypotenuse. And so we're going to set up 6 squared plus x squared equals 8 squared, and continue to look for the leg or solve for the leg by subtracting 36. You get x is 28, square root of that, and x is 2 radical 7. So setting up your cosine ratio, remember that the cosine ratio is adjacent leg over hypotenuse, so 2 radical 7 over 8, and simplify that to be radical 7 over 4. So I've got a couple of problems for you to put in your notes, and the first is, so you're going to use that last example as a way to model for this for these next two problems. And your first problem is, if tangent of A is equal to 4 over 15, then you're going to use that to find the sine of B. So I'm going to let you work on that. And then next is, if cosine of B is equal to 9 over 13, then I want you to find the tangent of A. So you need to use the last example as a way to help you get prepared for these two problems, work these two problems out. Pause your video, go back and watch the other examples if need be. So that finishes up one section for today.